In this lesson, we'll discuss accessing your server remotely from Windows. We're going to save your keys in Pagent this time. If you're managing a lot of Linux servers from a Windows computer, you may get tired of entering your password for your SSH key each time you connect to a new server or reconnect to one you were working on. Wouldn't it be nice if you could save your keys with the password already entered just once and use them every time you log into a server that has those keys? There is. It's one of the programs bundled with the PuTTY suite called Pagent. Storing your keys in Pagent is pretty straightforward. Just go to the Start menu, type Pagent, and just click on it when it comes up. It looks like nothing happened. It doesn't actually pop up with anything like most Windows programs would. But if you noticed, there's a new icon down here in the system tray, and that is Pagent. You can either right-click and select Add Key, or you can just double-click. Then click on the Add Key button. Browse to your private key. It should end in .ppk. You can double-click it or click it and then click Open. Enter your password. And you can see your key's been entered. Then you can just close this window. Your key will stay entered in Pagent. And if you want to connect now using PuTTY, you just load or double click, and you're in. No passwords to enter. You're all set. You could do this to as many servers as you want, as long as they have that particular key. You could also load multiple keys in Pagent and connect to multiple servers, as long as the key for that particular server is loaded into Pagent. This does store the unencrypted private key in memory, making it vulnerable to an attacker having access to your system's memory. But I know of no exploits available in the wild that take advantage of this to steal your unencrypted key. If you're uncomfortable with this, though, you could access your server as you've learned in other lessons. That's it for this lesson. Good job. I was updating the course from Ubuntu 18.04 to Ubuntu 20.04, and I came across an intriguing new line in the SSHD config file. And it was this line right here, include etc ssh sshd config.d/*.conf. So anything in this directory that ends with a .conf, that will be included. So I took a quick look at the man page for SSHD config, because this line was new to me. And it says this is a new thing that wasn't in the default with prior versions. And it says anything that's in this with a .conf extension will be included at the start of the configuration file, so options there will override those in the SSHD config file. Why would we want to do this? If you put your own configurations in your own file outside of the SSHD config file, and the SSHD config file is updated, you won't lose your changes because they're still in your own file. Also, we typically only want to change a few settings, and we want to do that consistently across our systems for the most part. So having this file, you can put it on any of your Ubuntu systems in that directory, and it'll work for you. So how does this work? First, we have to add this file. can see there's nothing in the directory to start with. So I'm going to call this 10mysshDstuff.conf. And the 10 in front is just a kind of simple way to tell which files are going to be read first. If I want a file to be processed after this one, I can call it 11. If I want it processed before, I can call it 9. And we'll just put the keywords and the arguments in here. That's all you really need. I will put a comment at the top so we know what's going on. We're going to turn the Debian banner off. We'll disable forwarding. So you won't be able to tunnel through this server. We're going to turn off root login explicitly. And we'll disable password authentication, but make sure you do not do this step until you've already tested that key-based authentication is working, or you'll be locked out of your system remotely. You'll have to go to the console somehow. We'll say permit empty passwords no. Even though that's a default, I just feel good having it explicitly spelled out. And we'll save and quit. So we see that our file is there, and we see that it has the settings we wanted. Now all we have to do is restart the SSH service. And if you type reload, it won't kick you out of your session. I believe even if you click restart, it won't, but reload is a little bit safer. Now on another tab, we'll log in again to make sure SSH is still working. And we're in. So this is how I recommend setting up SSH on an Ubuntu 20.04 server. See you in the next lesson. This lesson is deprecated. That means it will no longer be supported. It's only here for legacy support. If you're using Ubuntu 20.04 or newer, please use the previous lesson as your guide for configuring SSH. If you're using 18.04 or earlier, then you would use this lesson. But please consider upgrading and using Ubuntu 20.04. Now that we have key-based authentication for SSH configured and tested, we can harden our SSH configuration. This is done in the etc ssh sshd_config file. So just to start us off from scratch, if you're in your home directory, you navigate to etc ssh. You can see one of the files in there is sshd_config. This is the file that's used to configure the SSH daemon. The SSH daemon, when it starts, will read this file and configure itself according to the settings in that file. It'll then listen for incoming connections on SSH. The default port for this is 22. Here are the things we'll do or check to harden SSH. Remember, SSH uses port 22 by default. I'm going to show you where that's set and how you can change it, if you want to. We're going to make sure that the protocol is set to version 2. Versions prior to 2 are insecure. we'll disable root remote access. So root will not be able to log in with SSH. We'll disable challenge response authentication, and we'll disable password authentication. So the only way you'll be able to log onto your device remotely is with keys, key-based authentication. So back in the SSH directory, because this is a system configuration file, we're going to make a copy of it before editing. First, it's good to take a look and see if you have other copies already saved. We don't have an sshd_config.0, so we'll make one. If you did have a .0 or .1 or .2, you would just increment to the next number. So we'll cp sshd config to sshd config.0. Oh, we have to do that as sudo, sorry. And we have our copy. This is the original, the .0. Now we'll go ahead and edit the file. You have to use sudo to edit this file. The file isn't that long, so we can just scroll through and look for what we need. That's it. But if you wanted to, you could just type a / and search for words as well. We're going to go back up to the top and just do this manually. By default, SSH listens on port 22. I'm personally not a big fan of security through obscurity, and we're going to lock down port 22 so it will be secure. But if you want to weed out some of the bad traffic you'll get on this port with people trying to log in randomly, you could change it to another port. To do that, all you would do is change it to the number you want, save, and restart the SSH protocol. You would also have to change your firewall to allow the new port. And you'd have to specify that new port on any clients you want to connect with. So if I wanted to connect to Theo, with the user Theo, to 192.168.254.105, and I wanted to do a different port, I would have to put a -p, and then the new port number. And then it would connect. And if you wanted to do that with Windows, with PuTTY, you would just put your new port in the port window. And you could also save that with your session so it comes up with the right port every time you want to connect. I'm going to go ahead and leave that at port 22. Just remember, if you do want to change it, you'll have to change your firewall settings, and you also have to connect to the new port on your clients. The next thing we want to check on is the protocol number. Make sure only number 2 is specified here. Older versions of SSH have security flaws that have been fixed in version 2. We want to explicitly only allow version 2. Next thing we'll do is disable root login over SSH. So on my file, it says prohibit password. We're going to remove that and just say no. You also want to make sure challenge response authentication is explicitly set to no. If this were set to yes, PAM, or pluggable authentication modules, could allow login over password even if you set password authentication to no here. I'm going to show you that next. So if we uncomment password authentication and explicitly set this to no, password authentication will not work. However, that could be overridden by PAM if this is enabled. So we want both of these set to no. One thing you won't see here is anything about maximum login attempts. If we scroll all the way down to the bottom of the file, we can see that it says use PAM, and that's set to yes. PAM, as I mentioned a moment ago, stands for Pluggable Authentication Modules. And it's used to control how things log in, not just with SSH, but also with SSH. I just wanted you to know why it's not addressed here. We're disabling password authentication completely, so it's really not relevant for SSH. But I want you to know why it's not spelled out here, but it still works. In a future lesson, we're going to install something called Fail2Ban. Fail2Ban is a free open source application that watches for malicious activity like failed login attempts and blocks the IP addresses sending such requests. It can be used to protect many services, but we're going to configure it for SSH. So once we're done here, we save our changes. So it's escape:\wq. We can look at the difference between sshd-config and sshd-config.0. And we can see that permit root login used to be prohibit password, now it's set to no. And password authentication has been uncommented and explicitly set to no. Now these changes haven't taken effect yet. We have to restart SSH to make them take effect. To do that, it's just service sudo service SSH restart. Now, while we're still logged in on this session, we want to try and connect from another server and make sure everything is working. And we're in, so we make sure sudo works. And we're good. So everything works, and we could close our session and get on with our day. Great work. In the following lessons, we'll configure two-factor authentication, or 2FA, on your Ubuntu server. If you want to add an extra layer of protection to your authentication on your server, 2FA can help. We've already enabled key-based authentication, and you should have a password set on your SSH key. We've disabled root authentication over SSH and password-based authentication to SSH. This makes authentication to our server quite secure. What if someone gets your SSH keys and cracks or obtains your password for the key? The chances of this should be pretty slim, but if it happened, the attacker would be able to easily log into your server. Enter 2FA. It's free and easier than you may think to enable 2FA on your Ubuntu server. We'll cover the following: an overview of 2FA and how it works, apps you can use on your phone to authenticate, adding 2FA to your server, and how to recover from a lost, stolen, or broken phone. That's it for this intro to 2FA. I'll see you in the next lesson.